Okay, hello Cloud Gurus and welcome to this lecture. In this lecture we're going to look at DNS, and this is an introductory guide to DNS. This is purely an introductory topic. It's not supposed to be any kind of deep dive into DNS. DNS is one of those things that you learn a lot more as you get more and more experience with it, so as you play with it more. So what is DNS? Well, if you've used the internet, you've used DNS. DNS is used to convert human-friendly domain names, such as acloud.guru, into an internet protocol address, such as HTTP 82.124.53.1. And IP addresses are used by computers to identify each other on the network, and IP addresses commonly come in two different types, IPv4 and IPv6. So DNS, just use the analogy of a phone book. Hopefully most of you are old enough to remember what a phone book is. There's probably some people out there now who have never seen a phone book, which is a scary thought. So if you're looking up someone's name in the phone book, you look up their name and that will resolve to their telephone number. DNS works exactly the same way. You're just looking up a domain name, which resolves to an IP address. So that's all DNS is. IPv4 versus IPv6. So IPv4 is as old basically as the internet itself. It's a 32-bit field. It's been around for a long time, has over 4 billion different addresses. So 4,294,967,296 to be precise. Now the thing about IPv4 is it was invented pre-internet days, and it didn't really account for how big the internet was going to grow. And if you think about IoT and you think about all the devices you've got connected to the internet, we are well out of IPv4 addresses. So IPv6 was created to solve this depletion issue and has an address space of 128 bits, which in theory is, and I'm not even going to try and read that number, but it's 340 undecillion addresses. And you might be wondering what the relevance is of these two pictures. I read a book on DNS once, and I always found this sort of interesting. If you take every single IPv4 address is a grain of sand, you have enough grains of sand to fill up a dumpster or a dump truck. So that's how many IPv4 addresses there are in the world. If you take every IPv6 address and it's a grain of sand, you have enough grains of sand to fill up the sun. So that is the difference in addressing space. There is a lot more IPv6 addresses than there are IPv4. Now, don't worry, you're not going to be quizzed on this in any of your exams. It's just important to understand that IPv4 is the past, IPv6 is the future. We're slowly moving towards IPv6. And most of DNS, though, right now works on IPv4. There are some IPv6 records out there. And you just need to know that the two different types of IP addresses. So let's start with DNS, and if we look at some common domain names, let's look at google.com or bbc.co.uk or acloud.guru. You're always going to notice a string of characters separated by dots or periods. And the last word in the domain name represents the top level domain name. And the second word in a domain name is known as the second level domain name. And this is optional and really depends on the domain name. So .com is a top level domain name. .edu is a top level domain name. .gov is a top level domain name. Now .co in .co.uk is a second level domain name, whereas .uk is the top level domain name. .gov.uk or even .gov.us or whatever. So .gov.uk, for example, that's going to be the second level domain name .gov, whereas the top level domain name is going to be .uk. And for .com.au, exactly the same. Now, it's important to understand this because when we learn how DNS works, we're always going to the top level domain name, so the very last domain. So .com or .edu or .gov or .uk or .au, etc. So these top level domain names are controlled by the Internet Assigned Numbers Authority, or IANA. This is in a big database called a root zone database, which is essentially a database of all available top level domains. And you can actually go and view this database right now by going to iana.org/domains/root/db. That will show you all the top level domains. So .guru is a newer one, same with .cloud. If you buy some of these newer ones and you set up an email, like I still have problems registering my acloud.guru email address because a lot of websites were built before .guru was a top-level domain, and it just says it's not a valid email address, which can be really, really annoying. So do bear that in mind if you do buy a brand new top-level domain. So because all of the names in a given domain name have to be unique, there needs to be a way to organize all this, and that's where domain registrars come in. So domain registrars basically organize it so that domain names are not duplicated. So registrar is an authority that can assign domain names directly under one or more top-level domains. And these domains are registered with Internet, which is a service of ICANN, which enforces uniqueness of domain names across the Internet. And each domain name becomes registered in a central database known as a WHOIS database. So popular domain registrars include people like Amazon. We're going to use Amazon themselves using Route 53 when we go and do the labs to register our domain names. GoDaddy.com as well as 123reg.co.uk. By the way, Route 53, the reason it's called Route 53, and this can actually come up in interview questions if you go and have an interview with Amazon. If you remember Route 66, it's the famous highway that goes across the US. Because DNS operates on port 53, Amazon decided to call it Route 53. So that's where the name comes from. So all DNS has a start of authority record. A start of authority record stores information about the name of the server that supplied the data for the zone, the administrator of the zone. So whenever you're doing a who.is against a domain name, you'll be able to hopefully pull the, who owns this, who is administering the zone, etc. The current version of the actual zone or the data file that contains the zone, and then the default number of seconds for the time to live file on resource records. So basically, whenever you're dealing with DNS, it always has a time to live, and pretty much you want it to be as low as possible, certainly when you're making changes, because that means that it's going to propagate out quicker. So time to live is, let's say I have hellocloudgurus.com, and it's pointing to one IP address, it's pointing to one server, and my time to live is 60 seconds. If I then go and make a change to that domain name, to that IP address, let's say I add another server or I remove the original server and add a completely different new IP address, the amount of time that that's going to take effect across the entire internet as a whole is basically equal to the time to live. So that's what a time to live is. So we've talked about domain registrars and we've talked about start of authority records, and you might be wondering, well, how does this all fit together? How does it actually work if I was to type in a domain name? So here is your user. Let's say she types in helloroute53gurus.com. All she's doing is she's basically saying, I need the IP address for helloroute53gurus.com. Now, if her ISP doesn't know the IP address, if no one else has cached it in their caches, and no one else has looked it up, basically, what your ISP is going to do is it's going to go to .com. And it's going to say to .com, do you have an NS record for Hello Route 53 Gurus? And the NS record will look something like this. So if it is registered, which has been done through a domain registrar, you're going to have helloroute53.com. You're going to have the time to live. So this is the time to live, which is always in seconds. This is an NS record, and the NS records sit with ns.awsdns.com. So then what's going to happen is your server is, your ISP is then going to go ahead and contact ns.awsdns.com. It's going to say, do you know helloroute53gurus.com? And of course it knows it because we've registered it through Amazon. It's going to point us to Route 53, and that's where we're going to have a start of authority record. And inside our start of authority record, we're going to have all of our DNS types. So we're going to have things like our A record, and we'll explain, or why don't we start with what an A record is. So an A record is the most fundamental type of DNS. This is the record. The A in A record stands for address, and the A record's used by a computer to translate the name of the domain to an IP address. So for example, acloud.guru might point to 123.10.10.80. So that's all that's happening. The user is looking up helloroute53gurus.com. It's basically doing an NS. If we don't have that cached, we're going to do an NS lookup, or we're going to do an NS record lookup on our .com, our top level domain name. It's then going to point us to AWS, which is going to point us to Route 53, which is going to have our start of authority record. And inside that file, we're going to have things like our A records, and our A record will point us to an IP address. and then we'll be able to go straight to that IP address and start loading hello route53gurus.com. Now, explain to TTL, I'll just explain it again. Basically, it's the length of time that a DNS record is cached, either on the resolving server or the user's own local PC. And it's equal to the value, its name is time to live, and it's equal to that value in seconds. So 300 is 5 minutes, 60 is going to be 1 minute. And the lower the time to live, the faster the changes to DNS records take to propagate throughout the internet. So you want it as low as possible when you're making changes. So throughout the rest of this section of the course, if you see the option to change TTL to 60 seconds, do try. There will be a few instances where I forget it, and I'll leave it as the default for 300. If you do leave it as a default for 300 and you make a change, you go away, make yourself a cup of coffee, and wait for 5 minutes for that change to take effect. We can also look at CNAMEs, canonical names. There's a whole bunch of different DNS types. So A records is one, CNAMEs is one. We've got MX records, a whole bunch of different other ones. You're not ever going to be quizzed on these in the exam. You will need to understand these better for real life, though. A CNAME can be used to resolve one domain to another. So you could have a mobile website with the domain m.acloud.guru, and that's used for when users browse to your domain name on their mobile devices. You may also want to have the name mobile.acloud.guru to resolve to this address, and if so, you just create a canonical name. It maps one to the other, so you don't need to have all these A records for all these different things. You just have A record for one, and then you do create a CNAME, so you could have an A record for m.certifiedcloudpractitioner.com, and then you could have a CNAME, which is mobile, which maps back to M. So when someone goes to mobile.certifiedcloudpractitioner.com, it's going to say, hey, go check out the A record for m.certifiedcloudpractitioner.com. So it just keeps it simple. Moving on to alias records, which is why I was explaining CNAME. So alias records are unique to Route 53, and they're used to map resource records in your hosted zone to things like elastic load balancers, CloudFront distributions, or S3 buckets that are configured as websites, etc. So alias records work just like a CNAME in that you map one DNS name to another DNS name. So www.example.com to another target DNS name, which could be the actual address of your load balancer. So elb1234.elb.amazonaws.com. Key difference, a CNAME can't be used for a naked domain name or zone apex record. So naked domain name is simply this. It's example.com. There's no www in front of it. It's literally just the domain name and then hopefully the top level domain name, or it could be the secondary top level, .co.uk, etc. But it just means there's nothing in front of the domain name that you registered. So there's no www, there's no mobile, there's no sales, for example. It is literally just your domain name and then the top level domain name. And so with CNAMEs, you can't use them for naked domain names. And this used to be a big problem with Route 53. So then Amazon came out with alias records, and alias records basically allow you to have naked domain names that point to things like elastic load balancers or point to things like CloudFront distributions or S3 buckets, etc. So alias records are a pretty important part of AWS. So what are my exam tips? Well, just remember that elastic load balancers themselves don't have predefined IPv4 addresses. You always resolve them using a DNS name. So when you're creating a when you're creating a naked domain, or when you've got a naked domain name like example.com, and you want it to point to your elastic load balancer, you're going to use an alias record, and that alias record is going to point to the DNS name of your elastic load balancer because you do not have an IPv4 address for that elastic load balancer. Understand the difference between an alias record and a CNAME. So alias records can be used for naked domain names, whereas CNAMEs can't. And given the choice, you always choose an alias record over a CNAME, certainly when it comes to your exams. Start of authority records. This is just information stored in a DNS zone about that zone. A DNS zone is part of a domain which an individual DNS server is responsible. And so this is basically where you're going to store your A records, your CNAMEs, etc. and each zone contains a single start of authority record. And then alias records basically save you time because Amazon Route 53 recognizes changes in record sets that the alias resource record refers to. So for example, suppose an alias record set for example.com points to an elastic load balancer at this address. If the IP address of that load balancer changes, Amazon Route 53 will automatically reflect those changes in its DNS answers for example.com without any changes to the hosted zone resource record, without any changes to the hosted zone that contains the resource record set for example.com. So again, let's just say you've got a internal DNS name for your elastic load balancer like that. Basically, an alias record sits within Route 53. It's going to point to your elastic load balancer using its DNS address. And then Amazon do all the IP addressing for you. So your elastic load balancer will have an IP4 address, but you're never told what it is. It's basically mapped using Amazon's internal DNS servers to this name. If that IPv4 address changes, this name stays the same. And again, your example.com is using an alias record, which is pointing to this. So this name doesn't change. And if your IPv4 address changes for your elastic load balancer, it's not going to have any effect for example.com. So basically, long and short of it is using an alias record is a way of stably pointing your DNS at elastic load balancers. And it doesn't matter if their internal IP addresses change all the time. Amazon handle that all for you. You don't have to keep going through and updating Route 53. Now, don't worry if all this seems a bit full on. To be honest, in most of your exams, you just need to understand the different routing types, which we're going to go through. And that's what most of this section is on. So what is simple routing policy versus weighted routing versus geolocation versus latency, etc. That's what we're really going to cover. You're not really going to be quizzed on the difference between an A record, a CNAME, an MX record, a PTR record, etc. That's not what Amazon are focusing on. They're more focusing on how you use the AWS technology. Some common DNS types, so start of authority record, NS records, A records, CNAMEs, these are all ones that we've covered. MX records are mail server records, so this is what you use to point, if you've registered a domain name and you want to use Google's email service, you would basically point you'd point to Google's email servers using the MX records. And then PTR records are a way of doing reverse lookups, so it's just a way of verifying that you own the domain name. So these are all common DNS types. Again, like I said, you're not going to be quizzed on this in any of your exams. So what you really need to know is the different types of routing or routing that are available using Route 53. Now, we are going to cover that not in the next lecture, but the next lecture after that. In the next lecture, I'm just going to show you how to register a domain name, because you're going to need a domain name in order to do the rest of this section of the course. If you don't want to register a domain name, it does fall outside of free tier, so it's going to cost you about $12 for a .com, and then Route 53 itself costs about $1.25 a month, so it will cost you money to register a domain name. You can just watch me do it. It's entirely up to you. So let's go ahead, log into the AWS console and figure out how we can register a domain name in the very next lecture. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you.